when both the crank oscillates. In first two cases where one crank is revolve and another crank is oscillate, and the first one case where both the crank revolves are already solved, and I shared the links also regarding that. Now in this current mechanism, we have to initially just read the data and we have to identify that the case is what kind, and then we have tried to solve in a 4-bar-chain mechanism. In a 4-bar-chain mechanism, O1, O2 is a fixed length. So this is the first statement which is common for all three cases. So from this first statement, we are not identified that the case is kind of what, right? Either the crank is revolved, both the crank are revolved, and one crank revolve and one is oscillate, or both the revolve, both are oscillate. So from second statement only we understand and we examine that these are the this is the case of what kind. Okay. O1A is a driver crank and O2B is the driven crank. The link AB is a connecting link. Take the initial position of the cranks and the connecting links as shown in figure. Here figure is given to you, but sometime what happens, this angle is already provided you, and as per the diagram that O1 AB and ABO2 is the same, which is equal to 110. Okay, so sometimes if they don't want to give you the figure on that time, they mention that data indirectly in the figure. So do not every time depends on this kind of figure, but start to understand the data from read it very carefully. Take O1A, take O1A 60 mm, O2B 70 mm, and connecting link AB 50 mm, where the angle is given to us. So we have to draw as per given angle. What we have to do or how we have to proceed. First, we are taking O1A 60 mm. After that, take angle O1AB is 110 and draw an inclined line that AB is equal to 50 mm. After end of 50 mm, mention B, and from point B, just draw the horizontal line BO2, which is equal to 7070 mm. Okay, so this is your basic schematic diagram, line diagram to initiate your third case of Horbachen again. Now, how we have to start? Take O1 as a center and draw an arc passing through A. Okay, very easy. To represent the locus of point A. I repeat, take O1 as a center, draw an arc passing through A to represent the locus of point A. Take O2 as a center now. Simultaneously, take O2 as a center, draw an arc passing through point B to represent the locus of point B. Now, initially we have to find the extreme point or extreme position of both the arc. in oscillation diagram, in one crank oscillation and one crank revolve, we also find the oscillation extreme point that we are getting here with the B1 to B12, and here same way. Here it will not possible, so we have to initially find both the extreme point. So to find the extreme point or extreme position of both the arc, either it may be the arc start from O1A radius or it may be start from O2B radius. So take O1 as a center and radius equal to 60, this 60 and this 50, and radius equal to 60 plus 50 means 110, and get two arcs cutting the locus of B, at B dash, at B dash and B double dash. Okay, and we have to take O1 as a center and take 110. Why? It may be 60 and it may be 50. So we have to get B dash and B double dash as the extreme point of B. After that, take O2 as a center and radius equal to, now we know that this is the dimension is 70 mm. So 70 and 50. So from point O2, take 70 plus 50, 120, and the extreme point where it may intersect A dash and A double dash. Okay, so we are getting very easily the extreme point or extreme position of point A and point B, which are focused with the center O1 and O2. If completed extreme point, after that take some points on A dash and A double dash on the locus of A. Assume that the crank O1A initially move clockwise. And we are right now assume that the O1A is move in the clockwise direction, and start the name mentioned with A1, A2, A3. Okay, initially before that you just join O1 with B double dash and B dash, and O2 with A dash and A double dash. Okay, whichever we are getting the extreme point from O1 and O2 center. So join that center also. So we have to not go beyond. This is the limit. This is the constraint where we have to not go beyond this. So for that we have to draw the lines from O1 and O2. Now, as we seen the diagram that here AB line is there, and from O1 A double dash, one line which pass from O1 A double dash and O1A. So there is one area. In that area, I can mention randomly 3 points, that A1, A2 and A3. Same way as A moves toward A double dash, you just remember that as A moves toward A double dash, simultaneously what happened? B will move toward B double dash. Okay, B will move towards B double dash. You just assume both the things, so it's very clear in your mind that if A is move with A double dash in clockwise, while on that time parallel B is move with B double dash in anti-clockwise. This will continue until B reach up to B double dash. Okay. After that, B will reverse the direction. ये कब तक होगा जब तक B is not matched with B double dash. After that, what happened? The B will change its direction, even though A will be continue through A double dash. At A double dash, A will reverse the direction, force B to move further towards the B dash. At B dash, B will be changed the direction. Okay, when B is reach at B double dash, B dash, then B change the direction and start towards the B double dash. But A is continue to move in towards the A dash till it reach to A dash. Then start moving towards A double dash. In this way, both the cranks complete one oscillation. Okay. As A is moved towards A double dash, simultaneously B is moved towards the B double dash. A is moved towards A double dash and it may be continue up to A dash. But what happened here? Here that the B is up to B double dash, it may be same position. After that, it may be reverse, so it may be get up to B dash, and once again it may start to reach up to B dash to B double dash. So now we have to locate the points as we are mentioned initially that A1, A2, A3 randomly, same way here B1, B2, B3 in this area from B to B dash A1, A2, A3, B1, B2, B3 simultaneously join A1, B1, A2, B2, A3, B3. Same way, this is the remaining portion where I mention the points randomly, that is 1, 2 and 3, and here also 1, 2, 3. You are free to take 4 or 5, but 3 is enough. Same way, here once again we are taking B1 dash, B2 dash, B3 dash. That dash may join it here. You can just see it here. It may be joined with 1, 2, 3. Okay, so this 1, 2, 3 here it may be reverse, it may be 3, 2, 1. So this point is considered with these as a joint. Now, same way, join the extreme point which may remaining at here. Okay, you are take random points. After that, take midpoint, whichever we are taking initially, that AB midpoint AB is equal to 60. Sorry, AB is equal to 50. So 25. A1 B1 M1 A2 B2 M2 A3 B3 M3. Same way you continue to remaining 3 point. It may be M1 dash M2 dash M3 dash, and same way when you join with this point in upper portion of the B area, or we are consider that O2 up to B dash, which is B3 dash, B2 dash and B1 dash, and it may the midpoint, and which may consider as M1 dash, M2 dash, and M3 dash, and join all the midpoints, you are create a very good smooth curve, which is known as your smooth curve, which passing from the midpoint of all the A dash B dash, A B, and A double dash B double dash. Okay, so this is the third case, very important case, when both the cranks are oscillates in forward chain mechanism.